Okay, having proven Kepler's second law, let's go to the first and show that Newton's law of universal gravitation implies that the orbits are going to be elliptical. So consider the individual motion of the bodies 1 and the body 2. The equations of motion are, this must be equal to ma, where r is the distance between the bodies, and the origins at the body 1. So we subtract one from the other and write, now we can define the quantity mu, which is g times the sum of the masses. So we substitute the acceleration, and remember that we only have the radial, so this becomes, so finding the orbit, that is the equation for the radius vector, means integrating this equation. So to do that, we do a change of variable. We define the variable u is equal to 1 over r, and the time derivative of r is then the time derivative of 1 over u, which is minus u squared u dt. Now, if on top of that you consider that u is a function of phi, then du dt is du d phi dot. And because u is 1 over r, this is minus r squared phi dot du d phi. Now we make use of the fact that r squared phi dot is the angular momentum, and it's a conserved quantity, it's a constant. So this is r dot is equal to angular momentum times negative du d phi. To find the acceleration, then you simply take another derivative. To get rid of the phi, you use again the angular momentum being constant. Write phi is equal to L over r squared. Write that phi dot is equal to L over r squared, and substitute that into the r dot dot. So we can now replace this r dot dot into the radial equation of motion, this one. Now I'll multiply all terms by minus 1, replace again phi dot with L over r squared, and now multiply all terms by r squared over L squared. So this is known as the equation of the orbit. It's an ordinary differential equation of the harmonic type, where the right-hand side is constant. The general solution of this equation is y is equal to c times 1 plus a cosine x minus x naught, where a and x naught are integration constants. Now, if we invert the solution from y equal to u to y equal to 1 over r, now we invert this, you find r. Now compare this with the Kepler solution. You immediately identify L squared over me as a times 1 minus z squared, a as the eccentricity, and phi minus phi naught as the true anomaly.